right, guys, we are jumping into Module 3 in Eureka Math. We completed Module 2. We took our test before break. Moving on to Module 3, and this is actually one of my absolute favorite modules to teach. It's all about adding and subtracting and multiplying fractions. It's pretty straightforward. I have a couple of different methods that we're going to be using this module to help us remember some tips and tricks, but we're going to jump in and work on fractions. So if you have your math notebook, which you should, I would like you to go ahead and write down for me lesson 2. And I have 4 warm-up problems here. So I kind of gave you a head start with these warm-up problems. I've given you a fraction, and then I wanted you to create an equivalent fraction to go with the fraction given. So if I've given you a fraction, I want you to find the equivalent fraction. Now remember, the equivalent fraction means any fraction that's equal in value. So for example, 2/4 is the same as 1/2. Or you could write down 1/3 is the same as 2/6. Equivalent fractions are the same exact value, they're just represented differently. So for example, if you have a dollar bill is equivalent to 4/4. All right, it's worth one whole dollar. It's just expressed a little differently. So you're going to be creating some equivalent fractions, and I'll do the first one. Oh, excuse me, guys. I'm going to do the first one for you, or with you. So the first one, you're going to find you're going to create an equivalent fraction of 2/7. Now I helped you out by saying that I want your equivalent fraction, the new denominator, to be over 21. Okay, so 2/7. To get 21, when you're creating any equivalent fraction, whenever you multiply the top by a number, you're also going to multiply the bottom by that exact same number also. So to get 21, I multiplied my 7 by 3. 7 times 3 is 21. Now, 2 times 3 is going to get me, oops, I kind of hit my little arrow here. Let's see, 2 times 3 is going to get me 6. So I know that 2/7 is equivalent or equal to 6/21. They have the same exact value. I'll come over here and do this one with you. I want to find an equivalent fraction of 1/4. So what's another way to write 1/4? Well, I told you I wanted you to multiply it by 3. 1 times 3 is 3 for my numerator. Well, if I multiply my top by 3, I've got to multiply my bottom by 3. 4 times 3 is going to get me 12. So that tells me, I'm sorry guys, I don't know where all these yawns are coming from. That tells me that 1/4 is equivalent to 3/12. It's the same value. Jumping down here, I'm going to go backwards a little bit. I'm going to be given the equivalent fraction. I want to find that original fraction. So what's equivalent to 4/12? Instead of getting larger, I'm going to go smaller. Well, I know that 6 times 2 got me 12. What times 2 is going to get me 4? Well, I know that 4 times 2 is going to get me, I'm sorry, not 4. 2 times 2 is going to get me 4. So 2/6 is equivalent to 4/12. All right, now this last one right here, I didn't give you anything to multiply by, but I kind of helped you out by telling you what I wanted that new equivalent fraction to end up being with the denominator. So I have 2/5 I want an equivalent fraction with a 20 as the denominator. Well, 5 times what is going to get me 20? I know 5 times 4 is going to get me 20, okay? So if I multiply the bottom by 4, I've also got to multiply that numerator by 4 as well. 2 times 4 is going to get me 8. So I know that 8/20 is equivalent to 2/5. All right? Now moving down to our concept development, I'd like you guys to write this down. You do not have to write down these questions right here. We're just going to be answering those questions by talking about it. But I would like you to write down concept development. I would like you to write down this, and I'd like you to write down the number line. Feel free to hit pause if you need more time. But today we're going to be working on adding fractions and showing how those look on a number line, in an addition problem, and in a multiplication problem. We're going to be doing it 3 different ways today. So again, go ahead and feel free to pause this if you need more time. But I'm just going to go ahead and get started. to show 1/3 plus 1/3 on a number line. So I'm going to start at 0 because that's where I'm always going to start at when I'm adding anything. I'm starting at 0. Then I'm going to go to my beginning 1/3, which is right here. So here's my first 1/3. 1/3. So from 0 to here, that is equivalent to 1/3. Now I need to add another third. Well, I don't have any more 1/3 fractions right here. I have 2/3, 1, or 3/3. But I know that the space between 0 and 1/3 is 1/3 space, and I know the space from 1/3 to 2/3 is also equal to only a 1/3 jump. So I'm going to jump to my next third. So that tells me that 1/3 plus another 1/3 is going to get me 2/3. That's going to be my sum. Now that's pretty straightforward. We've been doing that for a while. You've been working with number lines for a few years. But if we look down here, again, you do not have to write this down. It says, how can you write this as an addition sentence? What about a multiplication sentence? Well, an addition sentence, we've already got that down. It's right up here. We could say, well, 1/3 plus 1/3 equals 2/3. Okay, that's my addition sentence. But what about a multiplication sentence? Now remember, multiplication is just repeated addition. And in this case, I'm going to be continuing to be adding 1/3. I have two 1/3s here. So I can write this down as a multiplication sentence as 2, it's the whole number 2, times, get rid of that, times 1/3 equals 2/3. I'm multiplying 1/3 by 2 because I have two 1/3s. Okay, I have two of them. So I'm taking two wholes and I'm multiplying it by 1/3. And I'm going to get 2/3. So we've just expressed this in three different ways. We've expressed it on a number line, as an addition sentence, and as a multiplication sentence. So we're going to continue doing that by showing it as an addition or a number line, addition, and multiplication sentence on the back side here. So I'm going to zoom in. There we go. You guys do not have to write this the directions down, but I would like you to write down the number line, and I would like you to write down this addition problem right here. We're going to be solving and showing the answer to this problem on a number line, an addition sentence, and a multiplication sentence like I just stated, okay? But this time I have a three-part problem here. I have 3/8 plus 3/8 plus 1/8. Well, this is already shown as an addition sentence right here. Now when I'm adding fractions, I want to choose a different color. Let's choose green. When I am adding fractions, I never, ever, ever, ever in a million years, never going to happen, not doing it, never, ever, no matter who says you can, you can't add or subtract denominators, these bottom numbers. You can multiply them, but we're going to talk about that later. But you can never, ever, ever, ever add or subtract them. And when they're the same, so I have 8, 8, and 8, when they're all the same, you just rewrite it down as 8 because that's the part of the whole we're working with. Okay? So I'm not going to add 8 plus 8 plus 8 to get 24. I'm just saying, well, my denominator is 8, so it's 8. And only do that when it's adding or subtracting. Okay? But you can add and subtract numerators. You can only add and subtract numerators, though, when your denominators are the same. Okay? So my denominators are the same, so now I'm going to add my numerators. Well, 3 plus 3 is 6. 6 plus 1 is 7. So I'm going to have 7 8s. 3 plus 3 is 6, plus 1 is 7. So I'm going to have 7 8s. Okay, so I just have shown it in an addition sentence. Now I'm going to show it on a number line. So I'm going to start at 0, and I'm going to go to 3/8. So 0 to 3/8. Boom, here we go. Now I've got to add another 3/8. So 3/8 plus 1, 2, 3. 3 more 8s is going to get me to 6/8 right here. So here's 3/8, here's another 3/8. Now I've got to add that last 1/8, and that's going to get you right here to 7/8. So I also just showed my answer on a number line. Okay, different ways to solve these problems. Now I had to solve it as a multiplication sentence as well. But this one's a little different than the previous one we had because it's a 3-part problem and not all of the parts are the same or equivalent. I am going to start by looking for the parts that are the same or they are equivalent. I know I've got 2 groups of 3/8. So I'm going to start by just saying, well, 2 groups of 3/8 is just, let me grab my marker or my pen here, 2 times 3/8. Because I have 2 of them. And I'm going to put that in parentheses because I want to make sure that part gets done first. Okay? 3/8 plus 3/8 is the same as 2 times 3/8. Okay? Now, after I get that product of 2 times 3/8, which I know is 6/8, then I'm going to add my last 1/8, like this. Boom. Well, I know 2 groups of 3/8 is 6/8, plus 1 more 8 is going to get me 7/8. Okay? So that's how you're going to show this as a multiplication sentence. These are going to take some time to get used to. These are not super user-friendly. It's going to take a hot minute to get used to the multiplication sentence. But I want to at least show you the 3 different ways to express these. Addition, number line, multiplication. All right, jumping down here to the very last one. I would like you to write down same direct, or you don't have to write down same directions, but I want you to write down 2 2's plus 2 2's plus 2 2's plus 2 2's. We're going to show this as an addition, number line, and multiplication problem. I am running out of time, so I'm going to stop this video, come back for part 2 for problem 3 here.